Okay, in this screencast, we're going to try to show you how to use LoggerPro to analyze the motion of objects in one dimension by analyzing videos of those motions. So the first thing I'm going to do is open up LoggerPro. You'll find it under My Applications. Once it loads in, we're going to insert a movie that we can analyze. My movies are under Videos, under Video Analysis. I'm going to do Long Drop 2, which will be similar to Long Drop 1 that you do. I'm going to open or try to make that video as large as I can just so I can have the best chance to see it and pick up the various data points. If you make it too large, it'll become so blurry you won't be able to use it, but try to make it large enough that you can see the elements within. Now this video was created all the way back in 2000 by the people at Doane College in Nebraska. I'm just going to go to the next frame and you can see the setup. We'll go ahead and play the video and you can see the ball fall. Okay. So one step and here goes the ball. Here's the person's hand. That's where I'm going to end up starting this whole thing. Right. So once you've seen the motion a couple of times and feel comfortable with how it works, there are a couple of things you're going to have to set up and then some data points to collect. All your tools are here where it says Enable, Disable Video Analysis. Click on the arrow and it's pop up the tools to the right. Here they all are. One of the most important is to tell the computer what's the physical distance in the video in so many meters or other measurable. Now, click on the yellow thing that looks like a ruler, that's set scale. I'm going to click and drag a green line from top to bottom here. Now the people at Doane College have told me that is 2 meters, 2m, so I hit OK. Now the computer knows how much distance on the picture equals a meter in real life. Something else I'm going to want to set is where am I starting from. The ball again is up here. If I click a couple of frames ahead, I can see the ball fall. So this is the ball here. Now this video, not great video quality. So you're going to have to watch carefully for the ball. But it's right here in the person's hand, so I'm going to want to set the origin right here where the ball is. Now, as the origin is set up here, this to the right is positive and up is positive. That means everything falling down is negative. I'm going to prefer to work with downward as positive. So the way I can do that is just take and grab the yellow dot and rotate the axis. Now in this case I'm going to rotate it so it's reversed. Now to the left is positive and down is positive. That's a real great feature if you're trying to analyze something on an incline. You can set the x-axis to be along the incline as opposed to straight up or down. Once I've got those two things set, I'm really ready to start collecting data. I just need to collect on at a point, and then here's where the ball starts. And now I'm going to try to track the ball as it falls, which again with this video quality is not easy, but there it is. And I like to try to make a data point every frame if I can. I'm just looking for that blurry area where the ball is. It shouldn't fall too far each frame, so it shouldn't be too hard to do. But again, not the greatest video for this. The one nice element of this video is the ball is just about the right size to set your data point on. With larger objects, you have to try to pick a point, like the front of a car or the side of the ball. Here, your data point set, you can just kind of try to cover up the ball picture. Now you should notice that every time I click a data point on the picture, I get a corresponding data point over here on the graph. I'm just going to do that until I'm pretty much close to the end of the motion. And that's it. Okay, so now I've got my data points on the right. Now I'm going to press Control R. That's going to set all pieces of my LoggerPro. I got the video on the left, I've got the data table down here, and then I've got the graph over here. Now I can analyze this in a number of different ways. I can pick what I want. Now, since I'm falling straight down, that's Y, the vertical dimension. So I really just want the Y position. Now, since gravity's pulling on the ball is speeding up. I have a situation where I have accelerated motion, so I get a curve. I can check the fit of that curve by clicking on the function setting button. Now, if it is a parabola, it should be AT squared plus BT plus C, so that's quadratic. I try the fit, and sure enough, if you look at the line, it pretty much goes all the way through those points. That allows me to get some sense of what the acceleration and motion of the ball are like. Now I could click on the graph, I could put in the title, position versus time. I could then print this off, I'd have a copy of it to save. I could upload the data to a digital file, save as, and I can save the file. I can do lots of different ways to go onward from here. Now, something else we want to look at is what should the corresponding velocity time graph look like. Now, I'm moving in the positive direction and I'm getting faster. It's going to be one idea simpler, one geometric shape simpler than a parabola, which means y equals mx plus b, or a sloped line. So I'm going to look at that by clicking over here and changing to y velocity. Okay, there you go. Now, not every single point looks like the straight line. Here where I originally was starting, the ball wasn't moving very much. But if you look at this part right here, if I take and highlight that section and then do a best fit linear fit line, I get the line for that, and I get a slope of about 10.3. That's telling me that the acceleration due to gravity as measured from this video is 10.3 meters per second per second. It's right here, slope M. And it's in meters per second, so that's acceleration. The slope of velocity time graph is in fact the acceleration. Now the accepted value on the Earth is about 9.8 meters per second. So you can see with a relatively quick analysis, we got pretty close, within a few percent of the accepted value. If we wanted to improve that, we could use better video. We could use a more modern video camera. We could drop it over a longer distance. We could measure things a little more carefully and accurately, and we could figure that out for ourselves. Those are most of the tools. One other thing I can show you is that for the X position, the Y position, not the X position, which was a curve, I can figure out the velocity is what's increasing here. I'm starting out slow and getting faster. I can look at that. I can take that best fit line, and then I can use this X key, and I can actually examine information at various points in time. One of the things I can do is examine the slope at various points in time. Now my velocity, notice my slope here at the beginning started out very shallow, wasn't going very fast, and then as I got steeper, I was going faster, about 9.4 meters per second. So you can get the slopes that way and see if they're positive or negative using that M key, that's this one right up here. And you can also get just the straight up data as to where you were located by using the X key, how high off the ground you were. So you started out about 0.12 and then went to 5. So this thing fell roughly about 5 meters from the top of the bridge to down below where we stopped measuring. So again, great little tool here to analyze how things are moving and rapidly see how they're moving, and then figure out how fast, how far, acceleration rates, whatever kind of information you want about the motion. So that's it for how to do it. Hopefully you'll have success when you try your own. just ask questions and I'll do the best I can to help you out.